So this is the 2022 season forecast, and the picture you're looking at is the eye of Hurricane Dorian, as seen from the space station of September 2nd, 2019, as it was over Abaco Island. And this was a Category 5 historic storm with 225-mile-an-hour wind gusts that literally flattened and buried the under sand and water. And probably thousands of people perished there. According to the Netherlands, who came in and did a special forensic study, at least 3,000 people died there, that even though the country has not admitted to that at this point. Again, welcome to the news media, and we're 100% about adaptation and mitigation here. And of course, one of the biggest climate impacts here is hurricanes, and hurricanes are changing in their characteristics. I just want to go over a few because I always love these satellite pictures. What a wonderful world we live in from that perspective, that we can measure almost anything now from space. But this is Hurricane Ida, 150 miles an hour Ida, that came up the Central Gulf and explosively developed from a tropical storm to a Category 4, almost Category 5 in one day, and then hit New Orleans and went up to drown a lot of people in New York City as a remnant storm that struck and did a lot of damage up there and killed a lot of people. But last hurricane season was another barn burner here in the United States, and New Orleans has been hit 7 times in the last 2 years by hurricanes. Not just one, but 7 tropical storms, so kind of amazing. Of course, this was the first Category 5 storm ever to hit northern Florida. This is Category 5 Hurricane Michael hitting Mexico Beach up in the Panhandle in 2019. And some of you may be aware that there was a gigantic fire up there this year in the Panhandle. And that fire was the forest of 1.5 million acres of loblolly pine that were flattened by this hurricane. And now that it's dried out for 2 years, it's become a fire menace in northern Florida. So the impact of hurricanes and climate-induced hurricanes is really growing, and they continue years after a storm hits. This is, of course, our Hurricane Ida, Hurricane Irma, which went through the archipelago of Cuba, and Hurricane Irma in 2017 was a Category 5 at this point, and was a gigantic hurricane and entirely covered the state of Florida as it went up the central part of Florida, struck at Naples as a Category 4.
You mind if I?
And did billions of dollars of damage as it went through Florida. And by the grace of the archipelago of Cuba, hadn't the eye got tangled up there in Cuba, it would have been a Category 5 storm and come right up the west coast of Florida. So this is the sort of like the nightmare situation that we avoided literally by 10 or 20 miles here in the Sarasota area. Let's see if I can get this. There we go. I'm just going to show you from 2017. These are all the hurricane paths, and the ones that are in purple are super hurricanes or Category 5 hurricanes. So this is 2017, and you can see there were hurricanes all over the Atlantic Basin, which is the Atlantic Ocean, the Caribbean Sea, and the Gulf of Mexico. 2018 was another big year, and you can see Hurricane Michael, whoops, let me go, that came right up into, let's see, I'm not sure how I can, there we go. right into Florida and came up. You can see where it formed down in the Yucatan Strait and came right up the eastern Gulf of Mexico into northern Florida. This track of these storms now seems to be getting closer and closer to the west coast of Florida as the climate warms. There's definitely a pattern of shifting paths that are bringing these storms closer to Florida. This is 2019, and in 2019 we had another 19 hurricanes, and this time the Gulf of Mexico didn't have much going on, and they were in the Atlantic. I'm sorry, this was 16 hurricanes. And then 2020, which was the year we did the first hurricane forecast at the CAC, because we're only 2.5 years old now. But look at the Gulf of Mexico. And this is a fascinating year. The CAC first hurricane forecast was we forecast a record number of hurricanes. The record was 28 in one season, and we had 30 this year. But look at the Gulf of Mexico, the year before nothing, and then in 2020, we were just inundated with hurricanes, literally. And Florida somehow escaped. I don't know how it happened, but it somehow escaped. But this is the year that New Orleans started to get battered. And the reason why out in the Atlantic, you don't see that many hurricanes, especially close to Africa, you just see the green and yellow, those are tropical storms. Red and purple are hurricane when they were hurricanes. And it was because we had significant African dust that was blowing off of Africa into the Eastern Atlantic, and it cropped down the hurricanes, but it seemed to enhance the hurricanes as we got into the Gulf of Mexico. And then we have last year, which was another big hurricane year with 21 storms. The CAC forecast 20, and we had 21. So our first two forecasts were really bullseyes, and it's made the CAC sort of like a go-to place now in hurricane forecasting to see what's going to happen, and we're getting great coverage due to this. And a lot of this, of course, we'll talk in a minute, is climate induced. So this is what the frequency of hurricanes starts in May, as we're almost there, which is why we're doing our first forecast a month beforehand. And it peaks around September 10th, and then it starts dying off around the 1st of November. But you can see, I don't know, you really can't tell from this, but these edges in May and June and in November now are extending all the way into December. Now we're having hurricanes, and the hurricane season is actually getting longer as climate warms. And I think by 2050, we'll have hurricanes from April through December. So all the more good news, thanks to the warming climate. So the early season forecast parameters we look at, the most important inputs really are two, which sea surface temperature, which is something I think we've talked about a lot, and whether we're having a La Nina or El Nino in the Pacific. La Nina is cold water in the Pacific, and El Nino is warm water in the Pacific, and it has a big impact on hurricanes formation in the Atlantic. And once the season kicks off, then a thing called the Madden-Julian oscillation, the MJO, becomes important. And this is really a big slosh where half of the world is in downward motion, which tends to suppress hurricane development, and half is in upward motion, and that oscillates back and forth about once a month. So when the oscillation is in an upward trend over the Atlantic, it enhances hurricanes during the hurricane season. So this is the hot off the press analysis of sea surface temperatures in the Atlantic hurricane basin. And the yellow, red, browns, and reds are sea surface temperatures that are well above normal. The red, for example, is 4 degrees centigrade warmer than normal. That's a huge amount of warming from the point of view of being an anomaly. And you can also see in that little purple circle off of New England that the sea surface temperatures off of New England are historically warm right now, this early in the year. If you look in the Gulf of Mexico, you see that little finger-like thing pointing toward New Orleans and Northwest Florida. That's the loop current, which is currently up to 4 degrees warmer than normal for this time of the year. And when I see this in April, I start getting nervous because the temperature in Sarasota of the sea right now is already 76 degrees. And that is the level at which a hurricane can sustain itself while it's over water. So we're already in the hurricane zone. If we were to get a storm form, it could be a hurricane all the way from this southern part of the Caribbean all the way up into Florida at this point. Now, this is a close-up of what it looks like in Florida.
Shit.
And the red is 4 degrees or more above normal for this time of the year. You see a few little eddies of cool water there at the edge of the continental shelf. There's probably upwelling going on there right now. We have a very shallow continental shelf, and then it drops off to 1,000 feet within a few miles. And where that blue water is, that's what you see. It churns there for a while, but you see coming up from Cuba all the way, that vast, big pool of red there, south of the Florida Panhandle. That is the loop current, and it's already 4 degrees warmer than normal for this time of the year. The second one is La Nina, which is the warm water, the cold water in the Pacific. And if this is a little hard to grok at first, but where you see the little gray dot on the left side of the picture there, that is the current sea surface temperature. And it's about 1 degree centigrade colder than normal. The neutral zone, where we're not having a La Nina or El Nino, is minus 0.5 to plus 0.5. When it gets above plus 0.5, that's an El Nino condition. And when it's below minus 0.5, it's a La Nina condition. We now have 40 models that forecast El Nino or La Nina. When I was a young scientist, we had none. So we're sort of gone from alchemy to chemistry in our understanding and ability to predict things in my career. But right now we're in a La Nina condition. It's colder than minus 0.5, and 39 of the 40 models are predicting either neutral or colder than neutral conditions all the way through the end of the year. And if you look at how on the bottom, I don't know, can you see my cursor moving around? Alex?
Yep, we can see it, Bob.
Okay, so here's the temperature now. And so this is the observed temperature. And here's where the forecast starts. And this is March, April, and May, April, May, and June, May, June, and July, June, July, and August, et cetera, in 3-month packets. So it's an average. And you can see how the models are forecasting La Nina conditions. Why is that important? Well, it's correlated to wind shear in the Atlantic. When there's a La Nina in the Pacific, the wind shear in the Atlantic is less than normal. So let's talk for a second. What is wind shear? Wind shear is the increase of wind speed as you go up in the atmosphere. That's a pretty normal thing. As you go up, the winds get stronger. And when we have wind shear in the atmosphere from speed, and a hurricane forms, the speed at 30,000 feet is blowing the center of the storm downwind, while the storm on the surface along the water is anchored to the water. And so you get a tilt in the hurricane central core where the eye is. And when that happens, it keeps the hurricanes from developing into major hurricanes. But when there's not wind shear, the hurricane can stack up because there's no wind to blow it off its axis. And so you get the conservation of all of that energy. It becomes a very efficient system, and it converts the heat of the ocean into wind and rain at just an incredibly efficient system. It's a machine out there. And so once we know the wind shear is going to be low and we have high sea surface temperatures, then we know that we're in trouble. And that's the present case. So between 1960 and 1990, I chose this 30-year period because our first satellites came on board in 1960. And in 1960 to 1990, we averaged 12 named storms in the Atlantic Basin a year. The 1990 average to 2020 average was 14. I just showed you the 2017 to 2021 record of hurricanes in the Atlantic Basin. And there was never a year in those 5 years where the number was less than 16. The range is 16 to 30. And so hurricane formation is rapidly increasing as we are moving out. Major hurricanes are also increasing, Category 3 to Category 5 storms. And it makes sense. I mean, the number of hurricanes are increasing, and therefore there's more Category 3 and Category 5s with a much warmer ocean temperature. And of course, we're seeing these storms explode and become major hurricanes literally overnight now. And that is nothing that happened before very often. Now it's happening every single year. And that's a very important concern for us because we now have 23 million people living in Florida. There are 10 million people living in the CAC, southwest coast of Florida area. And if we have an explosive development of a storm north of Cuba, it could hit the west coast of Florida in 24 hours, giving little warning for people to leave. And so the question is, what do they do? I'm not sure we have dealt with that from a governmental point of view, emergency management point of view, and from what the public thinks. They think they might get 3-4 days to evacuate, and it might be less than 24 hours. And then we know that hurricanes are slowing down, like Dorian, for example, was 24 hours over the Bahamas with 200-mile-an-hour winds and wasn't moving at all. Harvey over Houston a few years ago dumped 60 inches of rain as it stalled out over Houston and created a debacle there. So here's the forecast. The forecast is for 22 named storms this year, one more than last year. At least 9 of them will become hurricanes, but possibly 11, and 5 major hurricanes. So it's going to be a nail biter this year. And, you know, at some point, one of these storms in the Gulf of Mexico is going to come up the west coast of Florida. It's just a question of when. I don't know if it'll be this year, but you know, we've been lucky in the last few years, and we were lucky in 2017 with Irma. That was forecast to come right over Sarasota, for example, and went 30 miles east of here. And that made all the difference for us, even though we had massive damage here, especially roofs and trees. It took weeks to get electricity back on Longboat Key, where I lived at the time. It was 11 days without electricity. And you can imagine a major storm hitting, say, Tampa, even a Category 2 storm, with power being out, say, for 10 days or 2 weeks. And in the middle of the summertime, where with no air conditioning, we would have a lot of deaths after the hurricane, not just from direct causes, but from people dying of the heat without air conditioning. Since satellites in 1960, I just wanted to give you the numbers here. We had, from 1960 to 1980, there were 7 Category 5s and 16 Category 4s. These are really super hurricanes. From 2000 to 2021, we had 14 Category 5s and 32 Category 4s. So from 1980 to 2020, that 20-year period, we exploded in these strong hurricanes as the Earth has warmed at double the rate since 1990, as it was warming from 1960 to 1990. So even though you say, oh, well, only a degree or two, it shouldn't really make that much difference. This is where the difference is being measured. It's not so much the temperature, it's the impact of what the temperature does on the system. And hurricanes are distributing all this extra energy going into the atmosphere. And it's a mechanism of nature to bring that energy from the tropics up into the northern latitudes. And it's evidently working quite well. So the other thing is our paths of these hurricanes shift over time. In June is when we have a maximum over the Florida area. Early tropical storms in the Gulf in June are common. They come up from the Yucatan and come up, and the maximum is right over the eastern Gulf of Mexico. But then as we get, say, into August and September, you'll see in August, the path really shifts to the tropical Atlantic and sort of up the East Coast. And then in September, the Gulf starts to get really active again. And October is really when this is where our super hurricanes generally hit in our area. The Yucatan Channel and Florida, and then up the East Coast become the favored areas. So this is the climatology now of how hurricanes move. And so our key times, not that we can't get them in August or in July, but our key times really for focused on Florida, the West Coast, are really June and then September and October. And this is what I was talking about before. Historically, these are the paths of hurricanes, and the red are where they seem to be migrating to. Research is saying now that by 2030, the preferred hurricane path, which was once out in the Gulf, will be up the west coast of Florida. So this is something we know. It is a forecast. It could be wrong, but it's probably correct to some degree. And so we have time to sort of get our act together. But after 2030, we could really be, sort of in a bullseye situation. Whereas now we have them every so often, as we should see higher frequencies here. The other consideration is that sea levels are up 9 inches since 1950. People say, well, no, the sea level really has, I haven't noticed the sea level going up. Well, we measure it every single day, and it's up 9 inches. So that is a fact. And it's up 9 inches right here and on the west coast of Florida. And this is very common on the west coast of Florida. stations are up about 9 inches where we take the measurements. So you escape for our heavily populated low-lying areas now that are impacted by the sea level rise is really a major concern, because prior to 1950, we had a foot or so of margin that we don't have now. And as these hurricanes are getting more and more intense, and we're getting more and more hurricanes, that means the storm surges coming in, even from minor hurricanes, are going to do more damage than they used to do. They used to pass us and we get a high tide and that was it. But Eta, which was a tropical storm when it was off the coast here 2 years ago, flooded, literally flooded Longboat Key and downtown Sarasota, right where our new traffic circle is. And by the way, that traffic circle is not being raised high enough to deal with what's coming here in the next 5 or 10 years. I don't know why that is. It's not really good, what I would say, planning. And even though people say it's the most commented traffic circle ever built in Florida, evidently sea level rise was not, it was discussed, but it wasn't planned for. And neither was the increasing impacts of hurricanes. I hope that doesn't happen again. And maybe it's not too late to build that up. It's not done yet. Anyway, infrastructure is really behind the changes in these hurricane characteristics. So here's the scenario that I'm talking about. With the warm Gulf now and explosive development, we could have a hurricane develop in that red zone north of Cuba and come in to the coast here in short time, leaving us with a big hurricane and little warning and a lot of people that can't evacuate. What do they do, really? Is anyone thinking about this? I'll give you an example about the exponential winds. Let's say Eta was 70 miles an hour, okay? If instead of Eta, we had a 100-mile-an-hour wind, we'd have a 10x damage from wind, and the storm surge, instead of being 3 feet, would be 5 or 6 feet. If we had a Category 3 storm versus a minimal hurricane, the damage would be 60 times more just from the wind. And a Category 4 hurricane would be 256 times. And something like Dorian or Irma would be 1,300 times the damage. So wind matters as it goes up. It's not linear. The damage is exponential. And I'm not really sure people really understand that. So here's a little depiction of what it would look like with a 3-foot storm surge. The bridges are not here, but this is Lido Key, St. Armand's Circle, Siesta Key, Philippi Creek, and along the coastline of Sarasota up to Bayfront Park. And all of those red areas would be underwater with a 3-foot sea level rise from a storm surge. 5 foot would be a lot worse than this. And you can see that a lot of these areas would be hard to evacuate after that. And 3 feet could happen before a hurricane even reached the coastline. This is Eta, and this is Coconut Avenue and Gulfstream Boulevard. The peak wind in that storm was 70 miles an hour, and I think the peak wind in Sarasota was 56 miles an hour. And this is downtown Sarasota. This is close to where the traffic circle is. And this was a picture from the Sarasota Police Department that night. So the burning questions we have, especially if warning time is short, is where will we go? Will you be underwater given your escape route? you really need to know as a person what the geography is in your area, because we could go underwater in a major storm hours and hours before the hurricane strikes, cutting off the evacuation routes. Talk to your government officials. What's the plan? It's not the plan that we had for 1960 to 1980 hurricanes does not work in 2022. It's not, hasn't really been updated for the kinds of storms we're going to have on a sea level rise that is already up 9 inches and is going up another 11 inches by 2050. Questions for local governments. How will your area adapt to these serious changes in hurricane behavior given the climate warming we've already had? What's the evacuation plan for citizens given the potential for shorter times to evacuate, especially the more flood-prone areas that are going to flood more often now? And when will you start raising roadway grades on evacuation routes to give people time to evacuate? Even as the storm hits, if the roads were 5 feet higher than they are or 3 feet higher, it would give hours more time for people to evacuate, especially the barrier islands. So here are the storm names for 2022. I really didn't think about this until it was done, but 22 and 22. So I went through the alphabet. These are all the storms. And if we go through all those storms, we'd have to repeat the alphabet again. And Andrea would be number 22. We'll see how accurate we are this year. So here's the basic thing. You got to have the plan and you have to be ready. You can't think about what you're going to do when there's a hurricane warning out. You got to think about what you're going to do now. This afternoon, we'll have this entire, there's an article that's been written on this that'll be featured on the CAC website. And by mid-afternoon or late afternoon, the entire video will be up so it can be replayed. All of you who are on here can use your social networking skills to get this out to all of your friends. Make sure they all pay attention to this, because one of the best things we have now is social networks that can alert a lot of people in a hurry, but they have to get used to looking for this kind of information on a social network rather than whether Kim Kardashian is going out with Kanye West tonight. So we should use the social networks for our own purposes. So thank you very much. And I really appreciate you attending today and wanted to give some time now for questions. Alex, can you come on and
Yep, I'm here. So I know we had, I don't know if you want people to unmute if that's easiest, but I know David had his hand up. So David, I don't know if you have a question.
I do. Bob, you and I spoke about the circle. And this is a great example that is in our backyard. And we talked about the fact that the project cost, if I remember you correctly, was 35 million. And the cost of raising the elevation 5 or 6 feet. So the escape route from Longboat, Lido, or Bird Key, there's only one way to get off, would have been enhanced at the cost of an additional 1 million. Am I recalling the numbers correctly?
well, so you know, I don't honestly. It's a swag on my part because I really don't know exactly the cost, but the area that has to be raised really is a relatively small area from that surrounds the Ritz-Carlton entrances. That area is flooding now, and if you drive by there, just look and see where the water level is in Sarasota Bay. It's right now at high tide, it would come over if the tide was 2 feet higher. And it does that. We know that it does that frequently now.
Yeah,
And we know
I
that.
featured I featured that photograph in a few things I published as well, and then took the same photograph in the middle of May, standing where that cameraman was when it was dry, to compare it. It won't take much to make it very difficult, if not impossible, to leave Lido Bird or Longboat Key in a storm surge. People will be trapped.
Well, it could definitely happen, and it doesn't need to happen. And this circle is just one of many public works projects that is going on that doesn't seem to have a climate screen, where when these projects are approved, they should be approved only if they are climate resilient projects. I mean, you know, it's taking a long time. Hurricanes are changing faster than our processes to deal with them, because we keep doing the same process over and over again, and we're not revising these processes to consider where the real threat is now. The threat has
Yeah,
changed. Our processes.
Einstein had words for that. He called it insanity. You've answered my question. Let's give room to others. Thanks.
Thank you. David, as always, thank you. Who else has a question?
Bob, we did have, I think it was like kind of a question, but maybe asking you to speak on a subject more from Elizabeth. So Elizabeth, if you're still here and you want to talk about what you typed in the chat, otherwise I can read it to Bob for you, but feel free to jump on and unmute if you would like.
Hi, Elizabeth. Thank you for coming.
Yeah, good morning, Bob. Great presentation. Yeah,
Thank you.
I know we're always considering, how do we adapt, but we one of the adaptation techniques is really shelter in place. It's really not likely that like 20,000 people or more, 100,000 people can leave this area to go inland. We saw what happened during Irma years ago. We need to acquire techniques to implement in how we can stay in place and be safe. And I know that includes some like social justice issues, because a lot of people are not able to leave, but they need to have a safe place to stay in place. And these sort of techniques include like landscaping and building codes, and like certain places to go that are local. It includes food, and how do we get clean water? How do we prepare for these so we don't have to just leave?
And soft shorelines and resilient shorelines that can take the water and disperse the energy of a storm surge so that it's not so catastrophic. Nature already builds that into coastlines, but now that we have 23 million people here, they've been altered significantly. And, the Keys are just loaded with people, and, they're 5 feet above sea level. So those people really do need to get out of there. But Sarasota and some of the areas, we need to be retrofitting buildings that can take large numbers of people and are Category 5 hurricane proof. And these buildings could then serve other purposes, like indoor tennis, for example, just to use a very hot topic right now here in Sarasota. But they could house other things. They could be schools. These domes that are built, like there's a dome being built in the Bahamas now, that's Category 5 proof, because it's a round surface and the wind goes around the dome and it doesn't really blow the building away. But when you have a building with hard edges, like our architecturally beautiful buildings here in Sarasota, those buildings can take a beating in a hurricane. So even though our building codes are really getting better for structures that are new. The old structures are just not up to what we're facing, and we really have to change our processes, our building codes, the way we approve things. When we have all of the COVID money that's come into the communities to bolster them, could be used to start getting ready for these events that we're going to have, so that we're not just reacting to a disaster, which we know how to do, but we're preventing the worst impacts of these disasters. And I really think we're missing that. A small amount of money on the front end would save 10 or 100 times the money on the back end. But we don't seem to have that culture where we plan for the future. We'd rather react to it than plan for it. And that's what we've
Bob,
done.
I totally agree. Now back to the soft landscapes, for example, I see time and time again the desire of bayfront or ocean Gulf front owners to just cut down the mangroves, for example, and the beach, the beach grasses and everything, and 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 for a better view, but they're not thinking about coastal resilience. They're just thinking about their short-term view of their. So I would like to see more education for people in coastal areas about the natural landscapes, which are so naturally resilient. If you put up seawalls, for example, and they're getting allowed more often than we would like, it doesn't allow them, the naturally grown mangroves, to back up and expect sea level rise. So it's just short-term
Thinking.
desire for a lifestyle rather than really think about our role in this changing environment.
I couldn't agree with you more. And, developers really are aware of these things, but they're only thinking about, getting their projects built, and they don't really care what happens afterward. So, I mean, this is where our building codes and our processes to approve all of these projects should have that climate screen on it now.
You would think, yes.
And we don't really have that consistently, and that's not just in any specific town or city, that's regionally. And the region really needs to have a resiliency plan. Every town can have its own, but we should all be working together towards some standards on how we mitigate the worst impacts of these things over time.
Well, definitely, that includes the decision makers. It has to, because the decision makers, they're they want more, like, tax revenue, bigger buildings and higher values and everything, but they've got to also defend the citizens by protecting us in this way.
Well, I love what you just said, because value will be protected by doing exactly that. It may not be obvious right away, but when towns are wiped out by these storms and the town that has been resiliently planned isn't, that'll be noticed, believe me. We haven't had that opportunity yet, but it's coming. So I really think that these things are really dovetail, but we're just stuck in doing things the way we used to do them, and we're not really thinking these things through. And one of the roles of the CAC is to elevate this conversation, and our membership is so important here, because for the most part, all of our members, we're the ones out there trying to change the world in a better way. And so we have to insist on these things, and our city officials can't ignore it. A lot of them feel like if I don't know, then ignorance is bliss, and that's how they operate. So
Yeah.
sometimes it's really hard to get the town officials to get interested, say in the CAC, because they don't really want to hear what we
They
have.
don't want to hear it. Yeah. Nor
Yeah.
the developers, especially the coastal developers.
Exactly.
But it would behoove them to do so. So
It would.
thanks,
Another
Bob.
question?
Yeah, Bob,
Yes.
this is Lenny. One place that all of this stuff intersects is you talked about how things are changing and how storms are becoming stronger and we have more of them. But the fact that the season is extending is very significant here because it extends into what we call the season. So the number of people impacted can quadruple. And it's just frightening to think about a big storm when people who don't live here experience it for the first time. We're headed to something that's really what could be really tragic.
Well, that's one thing that would definitely affect our economy if people stopped coming because they were worried about hurricanes hitting.
Yeah. The other thing is we talked a lot about what's happening, and it's all nature, and you've done a real good job of explaining it. But is there any real research going on to address what might be done to reduce the impact or redirect the storms or do something so that when we're under attack, we can do more than hide under the bed?
You mean weather modification?
Yes.
Well, to be honest with you, we tried that when I was a young scientist. Actually, when I was flying into hurricanes, we were seeding the hurricanes, and we did notice that seeding with silver iodide, and we did notice that we could take about 10% of the speed out of the hurricane. And so everybody was excited that we had an answer. But what we noticed is that the hurricane would die down for a while, but it would get bigger.
But
It
that was
would
50,
expand.
that's 50 years ago. My question is there any new technology that's being explored? Is anybody working on this, or is this just a crazy idea?
Well, there are people who are trying to come up with new ways to do it, but there's a big fear in the science community to geoengineer the world, because if you make a mistake, you might not be able to put the genie back in the bottle. So, I mean, we're talking about that in climate change as a last resort for humanity, but I don't want to see us doing that kind of stuff. I would rather see us insulate our buildings, for example, and cut 40% of the energy we need without burning another gallon of fuel, for example. We could do those things. Right now, we have the technology to do it, but we're just choosing not to do it. One of the biggest opportunities is not drilling for more oil or bringing oil in from Venezuela or Iran or Iraq or wherever, but it's to insulate our buildings and make them climate resilient. And we have all the technology to do that now. And some of these government programs that are handing away money ought to be handing it to those kinds of incentives so that people would do that, and it would cut our carbon footprint immediately. It's something we can all do right now.
Yeah, but that should be included in the dialogue. What are some of the things that we ourselves could do besides stuff that the government needs to do?
That's exactly right. And the CAC is really trying to get us to use the government for what it does best, which is it should protect life and people. If it doesn't protect the lives and the people, then it has no real business of being a government. I mean, that's the number one job of government. But we have to get into their heads, and we have to hold them accountable for results. And we're not doing that. So they go off and do what they've always done. And, you know how it works. We all know how it works.
Thank you.
Any other questions? Well, if not, I just wanted to thank every single person here. I see the list of people here, and I know a lot of you. And of course, I wanted to do this for the donors because we don't have a chance to get together except at the annual meeting. And I wanted to see like if this kind of thing would be fun, but if we can all talk together more often, and Lenny, you're always been, you know, right at the edge of development, whether it's a jet engine or the CAC or whatever. And of course, Lenny has talked at our conferences before and mesmerized the audiences with his presentations. And so we're delighted to have him as part of the CAC. But all of you people are really change agents, and we have to keep working together, whether we're together in a conference like this or we go out and we make it happen, because really that's the only choice we have at this point. We're going to have climate warming for the next 100 years, no matter what we do. The only choice we have is to adapt to it and mitigate the worst impacts. But in order to do that, we have to change the way people do business. And it's easy to do. It's easier to do than you think, because change agents bring hundreds of other people with them along the way. This is not politics. This is about getting the results to protect life and property of people and our way of life here in Florida. And that's what this first CAC is dedicated to do. By the way, in our annual meeting, which will probably be in November this year, we're going to talk about the triple threat of water from sea level rise, the hurricanes and storm surge, and major inundation events. I don't know if you heard about the one that just hit South Africa, but 400 people died yesterday as a mega rainstorm hit in South Africa and dumped 12 inches of rain in 12 hours. It was quite a major disaster unfolding in South Africa. So it's not just here in the United States that we're having these things, but it's happening all over the world as the climate variability increases, as the temperature does. Well, with that, I thank you very much for coming. It's 10 o'clock and we promised it would only be an hour. So thank you very much. And we'll let me know what you think about this, and we can have other events like this if you think these are effective in stimulating your own brain and also encouraging you to go out and help make it happen. Thanks so much, everybody.